Hi guys, welcome back to my channel. So today we'll discuss Leetcode number 2024, maximize the confusion of an exam. So in this question, we are given a string and along with that we are given an integer k. So what do we need to do here is that we need to generate, or our basically goal is to return the maximum number of consecutive T's or F's given that we can perform an operation. So this operation is that we can replace the F's or T's maximum number of K times so as to make that substring consecutive with either T's or F's. All right, so in this question, let us see if we replace the f with t and this f also with t, then we will get four t's consecutively, and that will be our answer. So, talking about the intuition, because we need to generate consecutive T's. Consecutive T's also, it means that we need to iterate through this string in an order from left to right. Okay, so it means that we need to generate a subarray, which means that we can think about sliding window as an approach. Also notice one thing, if let us call this f culprit here, because let us assume that we are aiming to generate a consecutive number of t's here. So in this case, if the count of f is less than or equals to k, then we can replace both the f's with t's to make the answer tt. But if in case if it was like tt and triple f, then in that case, the number of Ks the number of Ks have are greater than the this K is equals to 2 value. Then in that case, we will shrink the window. So let's see the solution here. Uh, in the solution, we are running two while loops, one for T and one for F. So in the first while loop, our goal is to generate a substring containing consecutive number of T's, and whenever we encounter an F, so this F we treat it as an culprit, so we will store its frequency out here. So we have taken two pointers I and J will go on till the length of the the string minus 1. And as soon as it encounters an f, we will increase the count of f's. Ignoring this while loop here, it will then uh, count the size of the subarray, right? And then hence store the maximum size and then do j plus plus. So looking at this example, first example, so j was 0. So looking at the first example, j was 0, right? So the count f in this case remains 0, and ignoring this while loop, the size of the substring becomes 1, then it becomes 2, then as soon as it encounters an f, the count f becomes 1. The count f becomes 1, but as this count f is still less than k, we'll ignore this while loop and calculate the size of the substring, because this f is only one, right? And we are allowed to replace all the f's that are less than or equals to this k. So what happens is that the size of the subarray becomes 3, sorry, the substring becomes 3, and then what we'll do is that we'll do j plus plus here, and then again increase the count of f to 2, but it is not greater than k. So this while loop will be ignored once again, and our max value will be stored here. And the answer in this case becomes TTTT, and the output that will be returned to us is 4. Similarly, this thing will happen in while. So we have replaced all f's with t's here, and the goal of this second while loop is to generate a subarray containing maximum number of consecutive f's. For the consecutive f's generation is our goal here, and we will take count or store the frequency of count t. Now let's look at the second example here containing unequal number of t's and f's. So in this example, t and t will go on fine, and as soon as we encounter an f, we will increase the count f to 1. Look at this k here, it is equals to 1, right? So this subarray is still here is absolutely fine because the count f does not exceeds the k value. But as soon as we encounter this f here, this creates a problem because it is not allowed. We can't replace this f. And here we wanted consecutive number of t's. And look, the count f now becomes equals to 2 and this while loop will run. This while loop will run. So the purpose of this while loop is that now this window till here was valid and now this window has become invalid. So what do we need to do here? We will basically shrink the window and increase the count of I to make this sub window valid. So we will uh, so for that, where do we need to place the I? So we will need to place the I at a position after an F. So look, basically it searches for F at the character I, at the index I, and if it encounters F, so we will increase the count of F and decrease the count of F and increase I plus plus. Let's understand this with this example. So earlier the I was at a 0th position and then we will increase the I here. Now this array is also not right, because it also contains 2f. So now again it will increase the count of I. Now the I comes here at this f. So again this array is this the substring is invalid. But now I is at this position F. So as soon as it encounters an F, it will decrease the count of F. F again becomes 1 and I comes at this T. And now this becomes our substring. Now this substring is valid. Why? Because it contains only one F, which is replaceable. So now the count F becomes 1 and we will come out of this while loop and then calculate the size which comes out to be 3 and now 4 and then 5. So now this new substring the size is 5 and then the output return will be 5 and then the same process happens in J and in the end we return the max variable. Talking about the time complexity of this solution is big of n. It is basically big of 2n, but eventually it is big of n, right? And then the space complexity is big of 1. And talking about the next solution, we can do this question using hash map, wherein we will be traversing the whole of string only once. Look, in the above solutions, we were traversing the string two times, one for T and one for S. But here we can traverse the string only once because this solution was or available on the internet. That's why I'm discussing this too. Here, this approach is based on the logical thinking that uh, that will it this hash map solution assumes that the character T or F which comes lesser number of times, we will need to replace that character. Right. So let's look at the solution. It is quite similar to the above solution, just a small change here in this while loop. So again, we have taken 2 pointers and we'll store the frequency of T or F that comes on the position J in this order, left to right. And in here, in this last line, we are similarly calculating the size of the substring. Right. So what happens in this while loop is that we are checking the frequency of T and F. We are checking the frequency of for T and F Out of both of them, the character who is which is occurring lesser number of times, we assume that this is the culprit and we need to replace this. So we will check its frequency. If that character's frequency is greater than k, that means that sub array is not valid. So in that case, again, we will need to shrink the window or the substring. So in that case, what we do is that we find out, in that case, we don't do anything extra. We just decrease the frequency of the character present at the ith position and then increase the I. No need to check for T or F here. We just simply decrease the frequency of the character present at I and keeps on increasing I, and this goes on till the character coming lesser number of times, its frequency becomes equals to or less than K. So this is the solution. Its time complexity is the same as above, but when you will submit both the solutions, you will observe that this hash map solution takes a little bit time more than the above solution. This because hash map data structure comes with an overhead of inserting and changing the frequency. We are repeatedly using this get operation, right? This adds to the overhead. So yes, that was all from my side. Thank you. Also, this solution is the best solution and the easier one to think as compared to the hash map solution. Okay, thank you.